I'm going to go ahead and now take these sum to products and product to sum formulas, and let's put them to use into actually solving for trigonometric equations. So we want to find all the solutions to sine of 5x plus sine of 3x equals 0. Okay, and so since it's a sum, we have a formula. We can use the sum to product. And it's nice if we can make it, if this was a product right now, couldn't we just set 5x equal to 0 and 3x, I'm sorry, we would set sine of 5x equal to 0 and sine of 3x equal to 0. But this is not a product, this is a sum. So that's why it kind of lends itself to, oh, let's rewrite this as a product, because we know that when we have a product, when it equals 0, we can just say each product equal to 0. All right? So let's go and do that then. So you might want to have just in front of you, I'm going to just rewrite this as the sum to product now. Okay, so that's going to become 2 times the sine of 5x plus 3x over 2. And we multiply that then by the cosine of 5x minus 3x all over 2. And that equals 0 then. All right, so I just rewrote the left side using the sum to product formula. Simplifying, we get 2 sine, that's 8x over 2, which is 4x, times the cosine, 5x minus, that's 2x over 2, which is just x, equals 0. So we have a product and equals 0, so we can say each factor equal to 0. So 2 sine x, sine of 4x equals 0, and cosine of x equals 0. Okay, so let's deal with this guy right here. So sine of 4x equals 0. Okay, so remember what we have learned here. If this is something other than just x, we think of this as just x, meaning the sine of what is 0. Okay, the sine of what is 0. And so let's think here. That's the point at, well, the point 1, 0, right, which is at 0. So that means I know that I'm going to set 4x equal to 0. Okay, now let me say y again. I think of the sine of what is 0? Well, 0, right? Okay, but I'm not going to say x equals 0. I have to say 4x equals 0. All right? And let's say there's one more on the unit circle. The sine of what is 0? Well, that's at pi. So I'm going to set 4x equal to pi. Okay, so if I solve for both of these, I get right here, I get x equals 0, right? And right here, I get x equals pi over 4. Okay, now pay attention very carefully here, because this is when, if you don't understand this point, because we're actually going to get a grip of solutions right now, but I need you to understand why. Okay, first of all, it says we're supposed to be in the interval 0 to 2 pi. Okay, so that's not new. But something that kind of creeps up on us is this, is that look at the function that we're dealing with. We're dealing with the graph sine of 4x equals 0. Okay, and the question that we need to ask ourselves is, what is the period of sine of 4x? Well, we know that the period of sine is 2 pi over b, right? And our b is always the coefficient of x. So really our period is 2 pi over 4, which is just simply pi over 2. Now the reason why it is extremely important to know what the period is because if we have a point at 0, the next time that this point 0 will land at that same position is when you add a period. So really, my solutions right here, watch, if I'm going to start at 0, if I add pi over 2 to 0, I'm at pi over 2. And now this point will land at that same point again when I add another period. If I add another period to this, or pi over 2, I'll get pi. But then if I add another period to this, I'll get 3 pi over 2. And if I add another period to this, I'll get 2 pi. But again, we don't include 2 pi, so I stop there. So right now, actually, we have 1, 2, 3, 4 solutions just from this one. Okay, so what I need you to understand right now is that you have to look at the period, because, you know, like our graphs go like this, right? I mean, they just keep going back and forth. And so if this is 0, this is pi over 2, then this is going to be pi, and this is going to be 3 pi over 2. See how it's just going to keep landing at the same spot over and over again, okay? Now let's go to our pi over 4. So if pi over 4 is one of the spots on the graph that it lands, I have to add a period to that, right? Well, from that pi over 4, if I add a pi over 2, that's going to be 3 pi over 4. But then if I add another period to 3 pi over 4, I get 5 pi over 4. And if I add another period to 5 pi over 4, I get 7 pi over 4. And if I add another one, but then I'm going to be at 9 pi over 4, which is bigger than 2 pi. So really, these are all the solutions that came from just sine of 4x. Okay, so we haven't even dealt with the cosine of x yet, but just from this, we got all 1, 2, 3, 4, 5, 6, 7. We got all 8 solutions. Oh, dude. Trying to get crazy up on me, dog. Okay, so hopefully that wasn't too confusing. You can replay the video again to hear the explanation again. But the trick was to find the period and keep adding a period to your solutions until you've reached past 2 pi, because then you have to stop there. Now, what about, cosine of what is 0? Well, that's at, let's see, that's at pi over 2, and that's at 3 pi over 2. Well, check this out. Pi over 2 is right here, and 3 pi over 2 is right here. And if I add a period to this, I'm just going to be back at pi, right? So really, none of these yield a new solution. So really, we don't even have to add pi over 2, because you're going to get the rest of these or some of these solutions in there. So this right here, what I have highlighted, would be our final answer.